everyone. This video is meant to talk about section 3.2. So in this section, this is solving linear equations by graphing, and I kind of deferred how to graph a function using a table from section 3.1 to this video because we need to use that skill here. So the first thing I want to talk about is what it means to solve something. So there's 4 words that you need to know. They mean the same exact thing. So I could ask you, find the solution. I could ask you to find the root. I could ask you to find the zero of the function. Or I could ask you to find the x-intercept. So all of these words, you're going to do the same process. The reason why we have a lot of different words is because solution kind of indicates that we're doing some sort of solving. So we're solving for x. So we might do that algebraically. The reason why it's called the x-intercept is because it is the x-intercept on the graph. So you have to find where it crosses the x-axis. The reason why it's called the zero of the function is because we know that when the graph crosses the x-axis, that means the y value is 0. And you haven't quite gotten to this point yet, but you'll learn that the y value and f of x mean the same thing. So the 0 of the function f of x is the same thing as when y is 0. Well, that's the same thing as an x-intercept. So this is when y equals 0. And the root, I'm not really going to explain that one. You probably won't understand why it's called a root until you get to algebra 2. So that one you just kind of have to know that it's the root. I'm sorry about that. But hopefully all of these are connected. So just looking at the graph real quick, if I have a graph, here's the x-intercept, that's always going to be x comma 0. Well, you would have to solve for x, or you would have to find the x-intercept on the graph, or if you notice the y value 0. All of those things are true. And so put in your brain, this word, this word, this word, this word mean the exact same thing. So you're going to follow the following process. So now let's actually get an example of how do we find the solution, x-intercept, root, and 0. So I could ask you this in one of two ways. I could give you something like find the 0 of y equals 3x plus 6. So there's 2 ways to solve this problem. You could solve it algebraically, which is what you guys are very accustomed to, or at least you should be. So algebraically means use your algebra, your manipulation skills to move stuff around and solve. So there's no graph in this. So to solve the 0, remember 0 means the same thing as x-intercept, root, and solution, and that means set y equal to 0, because that's what an x-intercept is. So 0 equals, sorry, I had my brain 2, but it is actually 3. 0 equals 3x plus 6. And so now you guys can just solve this for x. Subtract 6 from both sides, we get negative 6 equals 3x. And then we get x equals negative 6 divided by 3. Negative 6 divided by positive 3 is negative 2. So again, this is a point, negative 2 comma 0. This is the solution, root, x-intercept. Which one did I leave out? 0. Now if I wanted to solve it graphically, or solve by graphing, we need to basically graph this function y equals 3x plus 6. So this is why I held off in the 3.1 video about talking about making a table. So make your table. This is going to be x. This is going to be y equals 3x plus 6. Pick some x values. Pick at least 3. I require at least 3 because if you only do 2, you might draw a line and think it's right, but if you get 3 and they don't all form a line, that means you know something was wrong. So I usually try to pick positive and negative, so -1, 0, 1 are great ones to do. And so if I plug in -1, I get 3 times -1 plus 6. That's -3 plus 6. -3 plus 6 is +3. So we get the point -1, 3. Moving on, if I plug in 0, I get 3 parentheses 0. Always use parentheses when you're substituting. And then I get 3 times 0, that is not 3. I can't tell you how many times I hear students say that. Anything times 0, we learned that was a zero product property, is 0. And 0 plus 6 is 6. We learned that that was the additive identity. And so this is the point 0, 6. Plugging in 1, we get 3 times 1 plus 6. 3 plus 6, sorry, 3 times 1 is 3. That's the multiplicative identity. 3 plus 6 is 9. And so we get 1, comma, 9. So now your next job is just to graph those 3 points. -1, 3, 0, 6, 1, 9. So I have -1, 3. That means go left 1, up 3. 0, 6 means don't go left or right and go up 6. 1, 9 means go right 1, go up 9. And next you would take a ruler, and this is where it's super, super important to actually use a ruler and get some sort of straight line going. So let's see if I can do this. I might have to finagle it and move it around. I have a little bit of foreknowledge about what it should look like, so. Apparently, I added a bunch of little lines. Okay, so that is what it looks like. We're not done. If you remember, the question didn't just ask us to graph it. It said find the 0. Well, remember the 4 words that a 0 is the same thing as, or 3 other words. 0, solution, x-intercept, and root. So one of those words that I said was the x-intercept. So once you have your graph, and this was the most common mistake I had last year, is that students would do a fantastic job of graphing the function, but never actually answered my question, which was find the solution. Look at the graph, find where the x-intercept is, and x-intercept is where it crosses the x-axis, and that is right here, this point right here. So that point is -2, comma 0. So the x-intercept is -2, the root is -2, the solution is -2. What was the other word? I left off one. X-intercept, solution, root, and 0. They're all -2. And hopefully, you should see that that matches up exactly what we did algebraically. 2 methods to get the same answer. Looking at the other stuff, the other way that I could present it to you, instead of saying find the 0 of y equals 3x plus 6, you may see it as, and this is the way your book did it, instead of having this y written here, you'll see a 0 written there already for you. Well, if you see that, all that means is that they've already set up the algebraically for you. But you have to know that this 0 really stands for the fact that y is 0. So that you would have to infer, if I see 0 equals blah, 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 graph the related function, which is y equals blah, 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 blah. So here, if you see 0 equals 3x plus 6, graph y equals 3x plus 6, look at the graph, and find the x-intercept. So that's what you should be able to do for the homework problems on 164. So for example, number 1, number 2, 3, 4, 10, 11, 15, 20, 27, 28, so forth. All the ones where you see 0 equals. I didn't really talk about the other ones. I would just have you solving those algebraically. Now, one last thing about the solving algebraically. If you see, and this was an issue on our last test, if you see 2x plus 1 equals 2x minus 5, and I ask you to solve this algebraically, get all your x's to one side, numbers on the other. So I might subtract 1, and I get 2x equals 2x minus 6, negative 5 minus 1 is negative 6. Then move the x's to the left-hand side. Well, minus 2x, and then minus 2x. If you notice, this left-hand side is 2x minus 2x. 2x minus 2x is not x. If you have 2 candy bars and you lose 2 candy bars, you don't have 1 candy bar left, you're kind of out of candy bars. So if you have 2x and you lose 2x, you're left with nothing. Big fat 0. So you get 0 equals, and don't forget this negative stays with the 6, we get negative 6. And you might be thinking to yourself, that doesn't make any sense. Well, you're absolutely right. That is total nonsense. If you get a nonsense answer, that means that this is no solution. Say, no way, Jose, that is not possible. There's no way that 2x plus 1 is the same as 2x minus 5. And you're absolutely correct. You're done.